This is the Master Brewers Podcast, brought to you by the Master Brewers Association of the Americas, a volunteer organization dedicated to continually improving the products and processes of our membership since 1887.
Let's go!
Master Brewers brings you interviews with the industry's best and brightest in brewing science, technology, and operations.
Calm down, I'm moving too fast.
This Master Brewers podcast is proudly sponsored by Hopsteiner, a global leader in the hop industry focused on quality, sustainability, and innovation in new hop varieties and hop products. Contact our brewery sales team to provide you with the hop-related tools you need to craft your next great beer. For more information, visit hopsteiner.com.
Additional support provided by
Get to know Proximity Malt. We malt superior, European-style, low-protein varieties grown close to home in Delaware and Colorado. Domestically grown, precisely malted to style. With our team of seasoned experts and 2 brand-new malt houses, try what's really new in malt. Check us out at www.proximitymalt.com.
The numbers are one thing, but actually looking at it and feeling how dense the material is or isn't in each one of those screens. And one of the other ways to test it is to look at that pan. If that pan is nice and bright, it's flour, things are good. If that pan is dark, like we had at one point, you probably have a lot of husk damage somewhere. That dark colored is the dust coming off of the husk, and it's not going to convert. It's just going to plug up your lauter ton trying to run off your brew.
This week on the show, a real-life case study from America's oldest brewery.
Hi, my name's Kevin Sibbet. I'm with DJ Yuengling & Son Incorporated in Pottsville, PA. I've been with Yuengling for 30 years. Started in 1988, throwing kegs around and sorting bottles to becoming now the lead brewer for our Mill Creek facility, running the day-to-day operations of the brewing department.
This all came about because you upgraded your lauter ton in 2016. Tell us about that project. What were you working with previously, and what did the upgrade look like?
So we have a 26-foot lauter ton that's used. Most of this Mill Creek facility went together with used equipment. The only new vessel in the brew house was the kettle at the time. So we kind of had the cards that we were dealt with to make do with what we had with this used equipment, get everything up and running, and get beer into the markets as quickly as we could. And we did a very good job. The planning of this facility was very well thought out as far as from groundbreaking until production time. We did very well with that. But after we got up and running for a couple years, we needed to get back into the efficiencies and start looking at the dollars and cents and making sure that we're doing as much as we could, efficiently as we could, and save as much money as we could in the process of the production of all the beer we were doing. So this upgrade needed to be done because the lauter ton was kind of beat up as far as the floor goes. It was warped, had a lot of gaps in it. The gearbox was old. The arms, it was a 3-arm system, and the rakes actually turned to the plow position versus having plow bars like you have today in the newer vessels. So we knew we needed to do this and put a new floor in. We had another lauter ton, the sister lauter ton to this one, sitting down in Tampa at our other facility. So we had all the plates shipped up, modified them a little bit to reinforce them because we were making some big brews. We were making 650 barrel brews in this 26-foot lauter ton. And we knew that we were kind of, pushing the limits with it for many years, and we did what we could, but it was time to upgrade it and start getting more efficiencies out of it.
Yeah, and I think, like you said, I think there's a lot of other brewers in that same position sort of overloading their lauter ton. Why don't you talk a little bit about that? I mean, you already said the batch size, but give us a bit more information in terms of what the runoff time looked like, what the raking process looked like, and just how much you were overloading it.
Sure. We were doing 650 barrel brews, which meant we were somewhere around 352 kilograms per meter squared in that lauter ton. And industry standards, or the book says, one of those things. somewhere around 200 kilograms per meter squared is where you want to be. So we were way over. We knew that, but along with that, it had an adverse effect on what we can do with our milling, as far as our raw materials and making sure that we can get the most bang for our buck out of our raw materials. So 3-hour runoffs, a bunch of deep bed rakes. Sometimes it was just tough. We were trying to schedule brews, and we're doing brews every 5.5 to 6 hours. And by doing this upgrade that we did and looking at the milling and looking at the process, which every brewer should be doing in their own brewery, we learned a lot. And that's kind of why I put this program together, just to get people to open up their eyes and take a look at their own process and become the expert instead of somebody from the outside coming in. You should do this or you should do that. Become the expert and know your own equipment to the point where you're very well versed on every part of the process, from the raw materials coming in until the beer's going into a package.
I've got a lot of questions I want to ask you about the upgrade, but first I want to talk about something you just said. You just mentioned deep bed cuts, and I want to talk about that for a minute because there are a lot of craft brewers running raking units that aren't really good for anything but plowing out the spent grain. And I've shown the Kunze's lautering diagram to folks in the past who proceeded to look at me like I was from another planet. So let's talk a little bit just about the basic operations of a raking unit and how that works on a system like this.
So for us, the raking is very important, especially with a lauter ton that had that much material in it, to make sure that we're cutting the bed properly, making sure that we can get the sparge water down through and not plug the floor up. It was a challenge for us to control the speed of the arms and the height of the rakes to make sure that we could do what we needed to get the runoff in a shorter time and get the clarity of the work that we needed to see.
Talk about how that raking unit does. I assume, is it spinning continuously throughout the entire lauter cycle or not?
Yeah, we have the rakes moving the whole time. And what we found by doing this upgrade was we were able to slow the rakes down considerably. So we may have, at the time with the old system, been going about 1 RPM. So one arm, 3 arms, 3 minutes total time all the way around for one arm to go through. Today we're doing 0.07 RPMs, which is huge as far as gaining the clarity in the wort.
Yeah, a lot of those very large systems, that raking unit, it moves so slow you can barely watch it move almost, So you said that's roughly did you say about 4 minutes or so for a revolution or something like that?
Yeah, it's well over 4 minutes now with the new system.
Yeah, that's pretty good. So, and a lot of people, I just want to talk more about that diagram because a lot of people don't, not having operated units that have the height control. If you've got access to the Kunze Technology and Malting and Brewing book, flip it open and look at that lautering diagram, but it basically shows that raking unit starts off up at a higher position, and it shows the extract, come down throughout the course of lauter, and it shows the turbidity start off a little high and come down. It shows the pressure differential increase throughout the process, and basically that raking unit, it's turning the whole time, and it's stepping down as that DP is increasing. It's making deeper and deeper cuts to try to offset that DP. And if you look at the example in the textbook, then it shows where it cuts too deep and the turbidity spikes, and then they bring it and the DP drops way down, but they bring the unit back up, and that becomes sort of the don't go beyond this point mark. I don't know how much logic you have built into your system, but some of these systems are very intelligent, and there's a lot of automation in them.
Yeah, ours is very automated. We'll start out with about 6 inches of height with the rakes, so 6 inches from the floor. And as differential pressure starts to creep up, we'll drop down a 1/2 inch, and then we'll drop down another 1/2 inch. And then as it climbs up even further, and we get maybe to 20 as a differential, we might start to also slow down the runoff going into the kettle to try and just hold this back and get a little bit more time out of it until finally we get to about 30 inches differential, and we will stop the runoff, drop the rakes down to 0, cut the bed for 3 minutes, and then we'll start the process all over again. And this is just set up to be automated throughout the runoff.
Well, let's get into more about this project. Why don't you talk? I know we want to talk a lot about milling. Talk about what milling looked like before your upgrade.
Our milling spec at the time that we had was very loose, and it had to be because we were overloading the lauter ton. So we had some settings that were definitely not ideal for us, definitely not ideal for a 6-set roller mill. We have a Schmidt-Seeger mill with 3 sets of rollers in it. So our top was a 0.065, so 65 thousandths of an inch. Pretty typical as far as that size. But then the middle and the bottom couldn't be kept as tight as we wanted to, just because we were going to tighten up that bed so tight that we weren't going to be able to run off. So they weren't optimal, but we made it work until we did the upgrade, which was a big change for us to be able to tighten up that mill and squeeze more out of our malt.
And what were those numbers?
We were at 65 thousandths on the top, 55 on the center, and 45 thousandths on the bottom.
And I'll just do the quick math there for anybody who's used to the metric systems. That'd be 1.65, 1.4, and 1.14. Okay, so you got you get this new system in there. You get your new lauter ton up and running. And what does anybody do with the shiny new lauter ton? Well, of course you're going to crank down those mill gaps and put the pedal to the metal, right?
Yeah, we tried to squeeze some more efficiency out of what we were doing, but then we learned, with the floor being as tight as it was, as fresh as it was, that there's no way we can do this again. So we designed our brews to be 500-barrel brews, which allowed us to reduce the loading, which also allowed us to tighten up all the mill settings and get more out of our malt in the process.
All right. Well, let's talk about sort of that iterative process. So, after those first couple of brews where you tried to push it and things probably didn't go as great as everyone had hoped, what did you do then? How did you start to troubleshoot that process and make iterative improvements?
Well, the first thing we were doing was the sieve analysis and seeing what we were getting coming into the mill itself, and that kind of was an eye-opener there. So that's where we really started to change things around by seeing what we were bringing into the mill. The malt was beat up at that point, and we needed to find out why. Why was the malt in the condition it was before we got to grind it, before we could ever get it through the process to the lauter ton? So we spent a lot of time on the sieve analysis itself.
How often were you doing sieve analysis prior to this upgrade? Were you doing that on regular intervals, or like just when you changed your malt, or what?
No, we do them regularly here at Mill Creek.
Okay. And do you just use the ASBC Malt 15 method, or do you do something different?
Pretty typical setup with the sieve analysis, starting with a number 10 screen, going down to a 100 screen plus the pan. We usually do at least one a week, if not more, depending upon different style brews that we're making that week, or maybe a change in the malt itself.
Do you typically pull those samples from the mill sample port, or do you get them from the grist case or somewhere else, or what?
So they're coming from the common tube on the mill. So we're not doing individual ones for each roller. We're doing the combined sample coming out of mill, okay, and then shaking it out through the screens.
Coming up.
Keep the porosity of the bed in the lauter ton in the condition we wanted to be sure to run off in a timely manner and still get the ideal lautering efficiency that we wanted to.
I'm John Bryce, and you're listening to the Master Brewers Podcast from the Master Brewers Association of the Americas. Support for this podcast is brought to you by
ABS Commercial is a full-service brewery and parts outfitter. From our Raleigh headquarters to our Denver office, we proudly offer brewhouses and fermenters from 3 barrels and up, yeast brinks, boilers, kegs, chillers, tri-clamp, and other stainless parts, all with the quickest delivery and lead times in the industry. Learn more at abs-commercial.com or call 877-BREW-ABS. ABS Commercial. We are brewers.
Here's what's coming up on the Master Brewers calendar. District St. Louis meets at Anheuser-Busch January 17th. Is PCR right for your brewery QC program? Check out the Master Brewers webinar January 24th. The District Ontario Annual Conference is January 31st and February 1st. District St. Louis meets February 21st at Third Wheel Brewing. And the 2019 California Joint Technical Conference is February 28th and March 1st in Paso Robles. It's not too early to start making plans for the 2019 Master Brewers Conference. If you can only make it to one conference in 2019, this should be it. We're really mixing it up this time and heading to the Calgary Convention Center to see how Alberta celebrates Halloween. Will there be a costume party? Only Tressa knows. Check out the full calendar of events at mbaa.com for more details or to find a district meeting near you. Now back to the show. You mentioned earlier, you kind of identified that the malt was essentially beat up, I guess, before it even got to the mill, right?
Yeah, and that really opened our eyes to digging into our system. We do pneumatic unloading here at Mill Creek as opposed to gravity in a lot of other places or super sacks or a lot of 50-pound bags. We unload typically about 175 rail cars a year. So it's all pneumatic for us here at Mill Creeks. We really needed to dive in from the car itself all the way through till it got to the mill and examine every piece of pipe, every hose, every elbow, every diverter valve, for instance. Everything had to get looked at and identified if there was some type of a problem.
Okay, well, let's talk about some of the stuff you found and some of the changes that you made. I thought one thing was interesting. You mentioned that you replaced smart elbows with sacrificial elbows. I'm not familiar with that. Talk about that a little bit.
So smart elbows are an engineered elbow to try and cushion the malt so it doesn't get beat up going from one direction to another. And they have a little pocket inside. There's a couple different manufacturers, but we installed a whole lot of these to try and get rid of pipes that were being worn out. You get any type of wear in an elbow and it starts to cut. The tiniest hole will start to cut an awful lot of malt. So the idea here was to try and go with the smart valves or the smart elbows to make the turn and make it as gentle on the malt as possible. But we wound up finding out that due to the amount we had in there, it really wasn't benefiting us. We really went back to just the old black iron sacrificial elbows and decided to just pay more attention to them, schedule the inspections on them, and just really start paying attention to that part of the process. One of the other things we do is we use 4-inch stainless, I call them slinky hose for lack of a better term. They're a directional hose. And if you would turn that hose the wrong way, I guarantee you would beat up the malt. And the easiest way to tell the difference is to gently glide your hand on the inside of the hose. If it's smooth, pushing your hand or your fingers in, that's the direction of the flow. If you start to put your hand in the hose and it's real rough, well, then now you're going against what the slinky wrap or the style of the hose is. So you could damage malt real quick if just that hose is on backwards.
Makes sense. It sounds like you had a lot of variables during unloading, like different types of trailers and whatnot. What did you learn there?
We don't typically get a lot of trailers here, but from time to time we do. So one of the things we did was try and pay attention to that part. A dump-style trailer that would just by gravity flow to the back of the trailer and we would pneumatically unload off of that works very well for us here as far as being gentle to the malt. A lot of people get the bulkmatic style or the hopper style trailers, and those style trailers, depending upon how they're loaded, there could be damage done to that malt before you receive the malt. And if you open up the top of the car, the malt might look real good because the transportation of that malt has shaken a lot of the fines or the dust to the bottom. You're really not going to see that if you're taking a sample out of the top of it. Some of those cars are pneumatically loaded from a rail car, for instance. So you're transferring the malt an extra time before you get it to your facility. And in our case, we're offloading it pneumatically from that style hopper trailer as well.
What general conclusions did you make from that investigation? I mean, were there any sort of major red flags or ahas, or was it sort of death by 1,000 cuts?
I think it was just a matter of spending a lot of time going through the system and identifying each particular part. We sampled rail cars top and bottom. We sampled the malt before it hits the mill. We sampled the malt, if we could, dropping into a silo, just to figure out and identify different parts of the system that may be causing the damage. And like I said, we replaced a lot of the smart elbows that we thought were going to help us at this point in time. And they may work very well in someone else's system. But again, identifying our own system, we needed to go back to real long, large, wide sweeps to be a little bit more gentle with the product.
Let's attempt to demystify mill gaps a bit. You put up a really nice slide during the District Philly meeting, which I'll link to from the show notes, that shows typical ranges for mill gaps for 2, 4, and 6 roll mills. But even with guidelines, like a lot of things in brewing, there's a lot that depends on your situation. Talk about that.
The difficulty with trying to put this program together was to try and include everybody from the smaller breweries to the larger regionals or even bigger to get an idea of what they can and can't do with their malt. If you only have a 2-roller mill system and you're trying to shake out a whole sieve from a number 10 screen down to a 100, it's kind of difficult. You're very limited on what you can do with your settings. And as you get up into the 6-roller mill, you could really start to tweak and tighten up and get down to what you need as far as what your process will allow. So even though these are ideal settings that are in the slide, the idea here is it's a guide. It's not etched in stone. If you vary from it, you probably need to vary from it for a good reason. And that's something we found. We don't exactly have the same settings as what's in this chart, because what we do is we go through with the sieve analysis and we dump it into an Excel spreadsheet that our Tampa plant had created, and we can graph what we have in our sample compared to what an ideal sample should look like. And you can see where you might be close at some point, but farther away in another. And then you start asking yourself, well, do I need to be that far away, or can I tighten this up without having any type of adverse effect on my process? So the slide is a very good guide, but again, it's just a guide.
What do your mill gaps look like now that you've got everything dialed in?
The previous setup was 65 thousandths for the top gap, 55 thousandths for the middle, and the bottom was at 45 thousandths. The current setup today with a 500 barrel brew, as opposed to the 650 barrel brew that we were making prior to these changes, we went to the 65 thousandths to the top. Kind of stays the same because you still want to get just that husk in that first screen as much as possible. The biggest changes were the middle and the bottom. We went to 30 thousandths in the middle from 55 thousandths. The bottom we've taken down to 25 thousandths from 45 thousandths. So we're really getting a better grind out of our mill. And the sieve analysis itself, instead of just looking at the pans, we lay it out on a table. We lay it out, and here's the 10, here's the 14, et cetera, all the way down to the pan. And we lay it out and we look at it. The numbers are one thing, but actually looking at it and feeling how dense the material is or isn't in each one of those screens. And one of the other ways to test it is to look at that pan. If that pan is nice and bright, it's flour, things are good. If that pan is dark, like we had at one point, you probably have a lot of husk damage somewhere. That dark colored is the dust coming off of the husk, and it's not going to convert. It's just going to plug up your lauter ton trying to run off your brew.
You also do a husk density test, which is new to me. What does that do for you?
So this is something that our Tampa plant was doing for quite some time. And we got together once we started doing this project and going through it and just trying to identify some more ways to make sure that we're going to keep the porosity of the bed in the lauter ton in the condition we wanted to be sure to run off in a timely manner and still get the ideal lautering efficiency that we wanted to. So what we're trying to do with the husk density test is to take a 100 gram sample based on the percentage of the number 10 and the number 14 screen and put them together in their percentage of each, come up with as high as possible husk density in a graduated cylinder. So we're trying to shoot for at least 500 milliliter or more in a graduated cylinder to really have a good idea of being able to set that bed. It's a filter. It's no different than if you're using diatomaceous earth in a screen filter. For instance, you're setting up that pre-coat. You're setting up that bed so that you're going to optimize the runoff and not plug it. It's really the same thing with a lauter ton. So we were trying to make sure that we're getting as much as we can of each component of our grind, which includes the husk, to try and give it the channeling that it needs for the bed.
Any additional takeaways you want to talk about in regards to sieve analysis or any of the other tests that you were working on?
I would say spend a lot of time with it and sample. The more you sample, the more you're going to learn. You're going to see some trends and compare it to what your certificate of analysis is coming from your maltster and see where you are along with things. Sometimes if you see a change, maybe in the diastatic power or the coarse grind extract, you can make some adjustments to your recipe as well through the grind, or just raw material alone for that instance. If the CGAI is changing on what you have, you might be able to reduce the amount of malt you have to use and still achieve the same end product at the end of the runoff for the brew. So there's a lot of factors, but it's just a matter of digging down into it and repeating it over and over and over.
You're now producing substantially more barrels of wort every day from significantly less material. Give us the details.
We went from a 650 barrel brew down to a 500 barrel brew, which took our loading from 352 kilograms per meter squared down to 271 kilograms per meter square, which still isn't what the book says, but it's a very good start. And who knows, maybe based on what we're trying to do here or whatever somebody's trying to do in their brewery, you may not be able to achieve that 200 kilograms per meter squared and still achieve the same size recipe that you want to do. The biggest thing we saw was with the runoffs. We went from over a 3.5 hour or 3+ hour runoff down to a 2 hour runoff, which is huge. To be able to drop off a whole hour or more of the runoff and get rid of the deep cuts. Part of what we did was also the speed of the arms going through the bed. We were actually going at 1 RPM, which doesn't sound like a whole lot, but when we slowed it down to 0.07 RPM, which is huge. It really kept the bed intact. It kept the clarity up. The wort clarity really came up by doing that. So we cut down a lot of the turbulence in the bed. And we went from possibly only making 4 brews a day at about 2,600 barrels as a rough number to 6 brews a day, slightly smaller brew, quicker runoff, turn a lauter ton around quicker to making 3,000 barrels a day. And the biggest thing is we gained on our lautering efficiency and our overall BME in the brew house. The BME and the lautering efficiency itself really came up. The total BME coming out of each one of the brews, we're in the high 90s, which is amazing to see compared to where we may have been prior to this. We were a lot lower than that because of overloading the lauter ton and not being able to get the grind as fine as we could. But the biggest thing to take away from doing this is the money we're saving. We're really getting the most bang for our buck out of materials we're bringing into the brew house now. Being able to reduce the loading in the lauter ton, get the amount of materials to stay above the floor and not get through the floor, it was huge all the way through the process.
That was Kevin Sibbet here on the Master Brewers podcast. Check the show notes for a link to the presentation Kevin gave at District Philly.
The gist of this program for everybody when we did the slide presentation at Philadelphia was just to get people to open up their eyes, audit your system, take a look at whatever you have, whether you're bringing malt in rail cars or you're bringing malt in 50-pound bags. How are you transporting that malt to your brew house? Ask a lot of questions from your malt companies, the vendors, everybody involved in this process. Become the expert of your own system. Learn as much as you can about it. The sieve analysis is nice to look at the numbers, but the biggest thing that we've done with the sieve analysis, and I like to share with people, is lay it out on the table. Take each screen, lay it out, taste it, feel it, touch it, taste it. If that pan is not bright, if it's dark, you put your finger on it, wet your finger and put it on it, it's going to taste slightly bitter. It's not going to dissolve off of your tongue. If the pan's nice and bright because of it being flour, again, wet your finger, taste it, it should dissolve and be sweet. Right off the bat, you know that there's a problem, that you're getting some type of husk damage to your malt in the process. Next thing I would do is make sure you document everything. We document heavily here. We have a lot of data on what we do at our mill analysis and samples, and keep going over it. Go back through the data, go back through the process itself, review it constantly, and share that information like we're doing today. Getting that information out there and giving everybody an idea of what somebody else is doing might help them in their own process and be able to get more efficiencies out of what they're doing with their milling and their brewing as well.
Moving too fast.